this video, we're going to be looking at literal equations, and a literal equation is an equation that involves several variables. So in previous videos, we looked at solving equations. There's always only one variable in it, whether that be x, y, any type of letter. A literal equation, on the other hand, has several letters in it. So a few examples would be a lot of formulas that we have. So maybe we're finding the volume of a prism, and so we have that volume is equal to length times width times height. That would be a literal equation because I have multiple variables in there. Another one is maybe the equation of a line, and we have 3x plus 5y is equal to 15. That would be another literal equation. And so we're going to look at solving literal equations for a certain variable. So to solve a literal equation, you'll solve it like a normal equation. You're going to move what is added or subtracted to the wanted variable first, then what is multiplied or divided. Unless you have one of those special instances where the whole thing is being divided by a number, then you would multiply first. Like for an example, like number 5. Okay, so for this first one, we want to solve for y. So I want to get y by itself. You can kind of compare this to the equation 5 plus 3y is equal to 18 if we just got rid of that x. To solve that, we would subtract 5 on both sides first. And so here we're going to follow that same thing, but now it's just there's an x with it. So that means I am going to subtract 5x from both sides first to get 3y is equal to negative 5x plus 18. You notice here I put my x term first. I would get in the habit of doing that because when we are graphing linear equations, we're going to want to have that x term first as well. And now to get rid of that 3 in front of y, I need to divide. Here, since I have multiple terms on the right-hand side, I'm going to be dividing every single term by 3. And so I get y is equal to negative 5/3 x plus 6. Okay, let's look at another one. So here I have the area formula for a trapezoid, and that is that a is equal to h times base 1 plus base 2 all over 2. And here I'm wanting to solve for b2. So here's one of those instances where we're actually going to want to multiply first. I have this whole thing is divided by 2, so to get the 2 onto the other side, I'm just going to multiply both sides by 2. Kind of like what we did for problem 5 here. I multiplied both sides by 4 to get rid of it. And so I have 2a is equal to h b1 plus b2. And remember, I'm trying to get b2 by itself. I want to get this by itself. And so there's a couple of different ways that you could do it. You could go ahead and distribute that h in there first and then solve from there. However, like we saw in the very first problem that we did, I could actually go ahead and divide what's in front of that parentheses on the front hand. So I'm going to go ahead and do it that way. So I'm going to divide both sides by h. To get b1 plus b2. And now to get b2 by itself, I just need to subtract both sides by b1. And so I get that b2 is equal to 2a over h minus b1. Okay, now for this next one, I have k is equal to m over l minus n, and I want to solve for n. Now n this time is actually in the denominator, so this one's going to look a little bit different when we're trying to isolate it. I can't multiply both sides by m to get rid of it. I really need n to get out from underneath the denominator. So to do that, I'm actually going to multiply both sides by L minus n first. That way it's no longer in the denominator. And so when I do that, I get k times L minus n is equal to m. Now remember, we still want to isolate that n. And so I have a k and L with it right now. Just like we did in this previous problem, I'm going to go ahead and divide both sides by k first. So now I have L minus n is equal to m over k. I can subtract L from both sides. And I get negative n is equal to m over k minus L. And now to get rid of that negative in front of my n, I need to divide everything by -1. And so when I do that, I get that n is equal to, these are really just both changing signs, and so I'm just going to write this as L minus m over k. Okay, let's do one more. So here I'm wanting to solve for v, so I'm going to get v by itself. First, I see there's that 1/2, so to get rid of that 1/2, I can multiply both sides by 2. And so I have 2k is equal to mv squared. Here, whenever two letters are right next to each other, they're really being multiplied together. And so to get rid of that m, to undo that multiplication, I'm going to divide both sides by m. So I have 2k over m is equal to v squared. And now to get rid of that square, we have to remember that the inverse operation of square is square root. So to get rid of the square, I'm going to take the square root of both sides. And so I get that the square root of 2k over m is equal to v.